So now in this video, we're going to look at the zener diode. So the zener diode works differently than the other diodes that you'll use. There's also called an avalanche diode, which is basically the same thing. But for the most part, zener diodes are the common one. So in any case, use it completely differently. You use it to set a voltage at part of a circuit for whatever reason. And they come in different voltages. So on top here, I have a 5.6 volt zener diode, so they used 5V6. V is in place of the decimal point because you wouldn't see a decimal point there. And I ordered these from China, cheap. And I also got zener diodes in the Jono's Electronics semiconductor kit. And that's at 9V1 for 9.1 volt. So you grab the voltage zener diode you want. Use it reverse bias. So normally you're told don't put current through a diode reverse bias. Zener diodes are made specially so that you can do so. So that is one of the exceptions. So in any case, the load can be what you want. Just realize that you got to have a resistor to limit current through the zener diode. Once it reaches its zener voltage, it will start conducting current freely as needed to hold the voltage there. So you still need to limit current or else you'll burn out the zener diode. And then you got to take into account how much current the load will need and add those two currents together. That current has to go through the resistor. So there's things to figure out, but for this video, we're going to keep it simple. And we'll zoom in before we grab the multimeter. There you can see the resistors to the positive side of the supply. There's a black stripe right there. Might be hard to see. That's connected to the resistor. And then the side without the stripe, so that's the cathode. The anode over here without the stripe is connected to the negative rail, which is usually backwards of how you see most diodes unless you want them to block current. So that's how they are used. They're a release valve. If the voltage builds up above the zener voltage, at this point it will start conducting current as needed to hold that voltage there. So now we got the multimeter. I already have it on, set to measure voltage, and I've gone over this process before, the alligator clips to the probes, so that I can just take the other end of the alligator clips, which I crimped to jumper wires, and plug them onto the board so we can measure the voltage directly. So right now we actually have a negative voltage. That's because this power supply, when the output is off, here's the wires that comes to power it. When the output is off, it actually gives a negative voltage. So that's something to be aware of if that'll be a problem. So I hit the power button. So I have this set to only 1 volt, and you can see 1 volt right there. And we're going to need to hit that. There we go. We're going to raise the voltage. So there's 2, 3. It's keeping in line because it's below the 5.6. 5. Now let's go to 6, and you can see we got 5.6. 7, again 5.6, and then 8, 5.6. Now we're going to move it over to the 9.1 volt zener diode. These are 330 ohm resistors, by the way. And let's go to 9, and you can see it's a little shy of 9, but there we go. We got 9, even though there's 10 at the supply, 11, and 12. So I think this is the maximum for current. We want to go through that resistor and that zener diode. So it went up slightly, but it's holding pretty true. We're given 5 volts across the resistor and the zener, and it's holding that 5 volts pretty well. So now, zooming in, I have LED over here. This is our load. We already have it wired. The long lead, the anode, is up above the short lead, the cathode, because the short lead, the cathode, is going to that gray jumper. I'm going to grab this resistor, and so now you can see that this is a 220 ohm resistor. We only really want 5, maybe 6 volts across that resistor and LED. 6 volts is probably still plenty okay. And we can get an idea of how much current is flowing, but realize that's also going through this other zener diode right there. So about 20 milliamps of current total through this circuitry up here. And so it's 28 now. I don't know if you could see that, so I'll do it again. 20 when we remove the resistor for the 9 volt zener diode. And so you can tell a lot by looking at the current on the supply. So I'm going to yank that LED, And we got this other one down here. So again, this one's set to 9 volts right there. Again, 330 ohm resistor, which isn't having to pass near as much current. So there you can see we got, this is a 470 ohm resistor since we're protecting an LED from 9 volts. And there you can see we got 7.82 volts. And so it looks like that one pulled it down quite a bit. And so we might need a lower value resistor for the zener diode to pass this much current. We'll look at how much current's flowing, 32, and I'll remove the resistor, which is rather warm, from the 5 volt one. And there you can see the current went down. So I removed that resistor. So a lot of that current was for that circuitry there. So the zener isn't perfect. We're going to improve it later on. But it's still pretty handy. It holds a voltage pretty well. It's keeping us away from that 12 volts at least. So in any case, this is a quick video series. So I'm going to end it right there. Make sure you check out one of the other videos I'm posting. Click subscribe, like, the bell, all that. I will see you in the next video.